Hey there, statisticians. So let's start talking about a p-value, what a p-value is and what we use it for. When we make a hypothesis test, or we make a hypothesis statements, we're saying what I expect to happen and then what it could be or the alternative. So this p-value that we are looking for, our p-value is our probability of getting evidence for the alternative hypothesis, the H sub A. When we are testing our hypotheses, and we are always looking at this, we always test for the alternative hypothesis. And that way we will either reject or fail to reject our null hypothesis. And we'll see that later here in a minute. So what we know is small p-values give convincing evidence for my alternative hypothesis. So our small p-values give convincing evidence for our alternative hypothesis because they say that the observed result is unlikely to occur when if my null hypothesis is true. Large p-values fail to give convincing evidence for H sub A, because they could occur by chance. So let's look at this with an example. So if we look back at our free throw example, remember that kid who was playing basketball and he goes, "Oh, I'm an 80% free throw shooter." Well, so we're going to test that claim. So the free throw shooter from earlier made 32 out of 50 free throws. There we go. Or he shot 64%. Now, he either shot this 64% because of one reason. By accident, he was having an off night, or B, he's really not an 80% free throw shooter. He's closer to 64. So what we decided to do is we said, all right, here's what we're going to do. We're going to look at this and we're going to pretend he is an 80% shooter, and we are going to do a simulation 400 times of 50 shots each, because he did 50 shots. And we want to know how many times did he get 64% of those shots in or less. So when we make this simulation, is there convincing evidence that the player is an 80% free throw shooter? Now, I do not look for evidence for the null hypothesis. My null hypothesis says that the proportion he should make is 80%. That means he's going to make 80% of his free throws. I don't look for that evidence. What I look for is the alternative hypothesis. The probability, the proportion that he makes is actually less than an 80% proportion. Okay, so then I look at my chart. And what I am looking at specifically is right here, this 64. Well, how likely is it that he just had an off game? Or is this by chance? Well, this 64%, if he is an 80% free throw shooter, this is very unlikely to happen. 3 out of 400 times is 0.0075. So it did happen. So if the player is an 80% shooter, this should not have happened. Since the player did not shoot 64%, this is convincing evidence. He did shoot 64%. This is convincing evidence to support the alternative hypothesis. Because if I'm really an 80% shooter, should I have been this bad? No, if I was an 80% shooter, the probability of me being that bad is very low. So that leads me to believe, or I would reject the null hypothesis. So that p-score, look how small it is. A small p-value. That p-value is very small. Small p-values give convincing evidence for the alternative hypothesis. So this is my evidence for H sub A. I feel like I'm rambling a little bit. You'll have to let me know in class if I am. But this is very important. We're struggling with understanding what this graph is showing us. He should not have been this bad if he was really an 84% shooter. It should not have happened. It's very low probability of happening at chance. So what that means, he is less than an 80% shooter is what it's leading me to believe. So this low p-value is evidence that that for the alternative hypothesis to be true. So remember, the p-value that we just found, that p-value measures the strength for the alternative hypothesis. I have to stress this again and again and again. We are looking for evidence for the alternative hypothesis, not our null hypothesis. It's counterintuitive. All right, let's take a look at something else too here. So the survey of study habits and attitudes is a psychological test that measures students' attitudes towards school and study habits. Scores range from 0 to 200. Higher scores indicate better attitudes and study habits. The mean score for U.S. college students is about 115. A teacher suspects that older students have better attitudes towards school on average. She gives the SSHA to a simple random sample of 45 of the over 1,000 students at her college who are at least 30 years of age. In the study of older students' attitudes, the sample mean SSHA score was 125.7, and the sample standard deviation was 29.8. A significant test yields this p-value that's 0.0101. So explain what it would mean for the null hypothesis to be true in this setting. Well, the null hypothesis, right here, my null hypothesis, oh goodness, that should have been a lowercase. My null hypothesis is what I expect to get. I expect all U.S. college students to have an SSHA score of about 115. So that is going to be my null hypothesis right there, the 115. And notice this is talking about a population. Mu is the population. So if my null hypothesis is true, then the true mean SSH score is 115. I found what I was looking for. Then part B says interpret the p-value. Interpret this 0.0101. This is the 45 out of, no, I'm sorry, doing it right here in this. Well, this is the probability that a student would get that score. So assuming the true mean score is 115, there is a 0.0101 probability of getting a sample mean of 125.7 or greater just by chance alone in an SRS of 45 or older students. So what this, again, it's a very small SRS, a very small p-value. So what this means is I would tend to believe the alternative hypothesis, and the alternative hypothesis would be a higher score. Alrighty, so I'm going to help you out with a couple more of these issues. I don't think this video went very well, but it's getting late and I'm getting tired. So if we're going to work on one or two in class, if you got questions, please ask. This is very important stuff.